Gerald, could you tell us a little bit about your background?
Yes. I'm an aerospace engineer. Spent 40 years plus in the business. Started off with a little project called the X-15, North American Aviation. Did some work on the XB-70, and then the rest of my career was on Apollo and Space Shuttle. After I retired in 2003, I got involved with a foundation called the Aerospace Legacy Foundation, which we formed here in Southern California. And we created a facility called the Columbia Memorial Space Center in Downey on the site of the old North American Rockwell plant. So most of my activity has been focused on preserving the history of what we accomplished and what we did and my fellow retirees, and trying to share with the world and the younger generation just how we did that and what we accomplished. The last several years, I've been focusing my attention on public speaking. Did several video documentaries this past year for the Apollo 50th anniversary. Worked with PBS and
Gary, thank you very much. I want to do the roll.
Okay.
You get the actual started here. So
I'm going to move.
it is now approximately 5 after 7. I've said that this meeting is going to run for an hour. If people want it to go longer, I've actually got it set up to run for 2 hours. So it's all going to be kind of up to everybody how they want to go. I'm going to now go down the list of attendees. As of now, more people may join us, but I want to kind of get the show on the road. So Michael, go ahead and come off mute and just say a really quick introduction.
Yeah, like you see in the background, Apollo 12, the most famous picture, Conrad in front of another ancient spacecraft, Surveyor. And on the other side, an unusual picture, Apollo 12 logo, but not the moon, the Earth in the background, and not the names of the astronauts, but the names of our family members. I, my wife, and 5 children. And Apollo 12 was, for me, the most challenging because the members were at the Navy. I was at Navy too. And when we finished building our house, then I said, we have really landed on the Earth. And this picture we made to our family crest since then, and I hang it up today. If you want to know more about my history with Apollo 12, I can share my screen if you want, if there's time. I stop it. I see.
We finally got it up, Michael.
Yes, okay. Then I try to, yeah, I'm back again.
All right. Thank you, Michael, for sharing that badge. Jeff, why don't you go ahead and have a quick introduction, who you are and your chapter?
Hi, I'm Jeffrey. I'm Director of National Space Society. I formerly was Senior Vice President. I chaired the one ISDC, actually doubled off prior attendance, vice chaired 2 more, helped form the chapter's assembly, the vice president of my own chapter, and as an active board member, I attend almost all executive committee OPSCOM meetings, and I kind of look at my particular function is to bring things from one part of the society to the attention of others. And when things are done, to try to make sure the I's are dotted, the T's are crossed. Is that enough?
That's perfect. Thank you. Okay. Chris, why don't you give us a quick introduction? Chris Cerrone.
Okay, yes, Chris Cerrone. I raised a member of OASIS, Los Angeles chapter, National Space Society. I raised my children in Downey, California, home of Apollo. And, you know, obviously, all of the Apollo missions are just really important to me. That's enough. We'll go on to the next person.
Thank you, Chris. Okay, we're going to go to Phyllis.
Hi, my name is Phyllis. I'm with the Phoenix chapter of National Space Society. I'm also acting executive secretary for the chapter's assembly. And hi.
Next, we have Dennis Pearson.
Okay, my name is Dennis Pearson. I'm from NSS PASTA, the Philadelphia Area Space Alliance. I'm a former chapter's assembly chair, and I'm head of the regions of New England and thing. And my phone is ringing. Okay, that's enough for now.
Thank you, Dennis. All right. So next, Dennis Whipple. Why don't you unmute and tell us a little bit about yourself and your chapter?
Yeah, good. Yeah. Okay. Dennis Whipple from OASIS. Been a member for over 30 years. I have served on the NSS board. And I'm at Chris's house right now. We're both on the webinar this morning. Glad to be here. I've been a videographer most of the time. I do a lot of the NSS ISDCs and whatnot, and proud to be contributing in that way mostly, but not as active in OASIS as I'd like to be, but because I work on the weekends, but always keeping up on things, and really glad you guys put this together, and proud to be a member.
Thank you so much.
Thank you.
And then Gabriella, why don't you unmute and tell us a little about yourself?
Hello, everyone. I'm Gabriella Lindberg. I don't know as much about the Apollo missions, the subsequent Apollo missions as I'd like to, but I joined the National Space Society and got interested in space sort of in a more passionate way in the past 4 years with all that's going on in the industry. And I love talking to people, and one thing that comes up a lot is when they first got their passion, and it's almost always Apollo if they had any contact with that in their lives. And then you also hear a lot of people sort of coming back into being interested in and engaged in space things after sort of this dormant phase. But it's just really gets a twinkle in people's eye, and it's really nice to be around that kind of passion. And I definitely doing what I can to support humans going back up, because I just have seen the influence that Apollo had, and not only on those people who worked at NASA, but the rest of us, so to speak. And I think it would just be really good for everybody if they did that again. So I'm just here to listen, pretty much.
Great, thank you very much. We're going to go to Larry Ahern. And Larry, I saw your Beautifius face there for a minute. Come on and tell us a little about yourself.
Well, for all the people on the chapters saying, I am the great and powerful Oz. I'm the vice president of chapters. I'm also with the Chicago chapters here in Chicago. And unfortunately, I can say that I probably met a lot of these Apollo people, and I was an adult and not a child. So I'm really dating myself. So let's move on.
Thank you, Larry. And then Randy, I see you there. Could you unmute and tell us a little bit about yourself? There you go.
Randy Gigante. I'm on the board of the National Space Society, also on the policy committee, and just trying to get more people that would be interested in participating in March Storm in DC, obviously coming up in March 2020.
Fantastic. Thank you, Randy. And good to have you with us tonight. Okay, I noticed Jim Plasko showed up. Jim, why don't you introduce yourself briefly?
Hi, everybody. I'm Jim Plaxco. I think I pretty much know everyone here. President of Chicago Society for Space Studies, NSS Director of Information Systems. I got the extent of my personal involvement with Apollo 12 was having had the opportunity to spend a day with Alan Bean quite a few years ago. We spent a lot of time talking about his space art, which may well be his most important contribution to the space advocacy movement with respect to the fact that he used art as a way of promoting space and increasing public awareness in communities that are outside of the traditional, space advocate movement. So I have an interview with him on my website, artsnova.com. You'd have to use your search engine, just search on Alan Bean for the site artsnova.com. I don't have the URL handy for it. It was done back in the early 90s that I interviewed him. So it was really, his insights were fascinating into both the Apollo program as to his, motivations for getting involved in art. So, because you may recall that was a criticism that some have leveled at the Apollo astronauts, that because they were all engineers, they weren't particularly flowery in their descriptions, even though I would argue that Buzz Aldrin's description of the moon as magnificent desolation is very poetic. So, thank you.
You're very welcome. Thank you. Lawrence, I noticed you showed up. This is great to have you with us. Lawrence is also going to be one of our presenters a bit more at length. But just briefly, Lawrence, could you just tell us a little bit about yourself right now?
Yeah, sure. My name is Lawrence Kuznets. I was on console during all the Apollo missions, so I'm pretty intimately knowledgeable about a lot of it. So
that's fantastic. And we're going to get back to you later to talk about that in detail. Bennett, you're up. Unmute and tell us just a brief thing about yourself. Bennett Rutledge.
Well, I'm Bennett Rutledge. I'm a guy who one afternoon in the previous century was picnicking on the lawn with my girlfriend, a lady who is now in charge of the DC chapter. And I realized that Skylab had fallen out of the sky and that we were marooned on this planet. Ever since then, I've made it my purpose to move, touch, and inspire folks to reach out and take freedom of the solar system. And I'm here representing the Denver chapter.
Thank you so much, Bennett. That was very romantically put. Let's see. Then we got Dennis, we got Larry, we got Randy. Carol Redfield, quick, brief little introduction about yourself.
All right. Well, I was just talking with my son, Neil, who's named after Neil Armstrong. He's in the master's program at Southern Methodist University. Some of the people on here know him. I'm a professor and chair of computer science at St. Mary's University in San Antonio. I was a member of NSI and L5 when they both merged to be NSS 32 years ago. And I chaired the 1991 ISDC in San Antonio, where my husband, Joe, was treasurer. And at the point in time, it was the most financially successful ISDC. So that's how he became treasurer of NSS and has been since. And he's in the background here. And then just in case people didn't feel old enough already, a lot of folks here know our daughter, Crystal, and she's been accepted to 5 colleges as of today.
Wow, that's fantastic.
Yeah.
Thank you, Carol, and hi, Joe. Okay, Dave, why don't you chip in? Carol, you can go back on mute.
Hi, Dave Stewart. NSS Seattle. I've been with NSS since before NSS when it was L5. Been 2 different vice presidents, been on the board, and witnessed a little bit of history. With that, I'll pass it on.
Again, thank you very much, Dave. And we'll drop over to Perry Dutray. Tell us a little bit about yourself, Perry.
I'm an ambassador for the National Space Society. I'm located in Colorado. I go to roundtables, industry meetups, governmental meetings, sci-fi and media conventions. I speak with senators and Congress members, and I give presentations to the general public. I've been, when I was 4 years old, is when Apollo 11 and Apollo 12 happened. So I've kind of been interested in that since I was a very little kid. So that's about it.
Great, thank you. And we have the McMurrays.
This is Cliff McMurray. I'm the president of the Oklahoma Space Alliance chapter here in Oklahoma. I used to be the executive vice president of the National Space Society, and I've written quite extensively in the last 10 years for Ad Astra magazine. My wife Claire is with me, and she's very active with chapters, and she works with international chapters. Say hi, Claire.
Hi.
All right, so that's us. And let me not forget to take a moment to say schönen guten Tag to my very good friend Michael Steniken, who is on this call, and I have not seen in many years, and I miss very much. He was a very good friend of mine while I was in Germany, and got me to the launch site of the very first rocket to penetrate space, the ground zero at Peenemünde, and for that I will be forever grateful.
Sure, now on and speaking. Cliff, why don't you continue and do your presentation now?
All right. Well, I guess I must thank you for causing me to break out the books again and look back through some stuff about this incredible mission. The first thing I wanted to talk about was the fact that they were hit by lightning on liftoff. They were still burning on the first stage. I believe they were at 36 seconds or 63 seconds. I may have that backwards. And it was the first experience NASA had with turning their spacecraft essentially into a big lightning rod by going up through atmospheric conditions that between the friction of the spacecraft and the clouds produced lightning, which made everything drop out. It was I remember hearing Pete Conrad and Dick Gordon speaking at Oshkosh one year, and somebody asked them what they said when they saw every light on their instrument panel light up and their inertial guidance platform drop out. And Dick Gordon looked at Pete Conrad with a big smile on his face, and he said, "I dare you to tell him." And Pete Conrad got an equally big smile on his face, and he said, "Well, no, it really wasn't all that bad." But Conrad had a real reputation as having a really salty vocabulary as a sailor. And he said, "It really wasn't that bad. I listened to the tapes, and I heard this really high, squeaky voice. Somebody said, set a switch SEC to aux, and a really high, squeaky voice said, 'What's that?' And that was me. And somebody else said, 'I know what it is.' And that was Al. And Al Bean, who was the lunar module pilot and shouldn't have known this, knew where the switch was, and he turned it, and they got all the instrumentation back. That was thanks to one of the ECOM on that mission in mission control was John Aaron, who comes incidentally from Oklahoma, and he was knowledgeable enough to make that call on the fly, got them to orbit, and they were at that point concerned whether or not they had fried the pyrotechnics in the parachute package, which would mean the parachutes wouldn't open when they came back. And they had some discussion about that on the ground. Should we bring them back right away? And Chris Kraft said, no, there's really no point in doing that because, you know, the parachutes will work or they won't work. We might as well send them on to the moon. So they sent them to the moon. And then the next task was to have this first precision landing. Now, on Apollo 11, all the time they were on the moon, they didn't know where they were. They had landed 3 miles long. They were completely outside the landing ellipse. And Sam Phillips, who was the head of the Apollo program at that time, General Sam Phillips, was looking at this and saying the next landing has to be a pinpoint landing. They had no idea how to do that because the gravitational field of the moon is lumpy. It has these mass concentrations, which I think we still believe are the remnants of very large meteor impacts in the formation stage of the moon that made the gravitational field of the moon lumpy. So you would as you go over it, the orbit is over time unstable, but in short periods of time, it will just change in ways that they really hadn't mapped out well at that time. So how are they going to do a pinpoint landing on the very next landing? Well, they got together and a bright young man named Emil Schleicher, who Neil Armstrong said was the smartest guy in the whole organization that he'd met, said, we can do it with Doppler because as the spacecraft comes out from behind the moon and transits the face of the moon, we're going to have this Doppler shift. And we know what that Doppler shift is supposed to be as it approaches the landing site. So if we see any deviation from that, we'll know how much deviation it's deviating from the trajectory, the proper trajectory. We just need to map it back onto the proper trajectory. Okay, now we know where things are. How do we get the spacecraft to respond to that? Normally, if you want to change the notion of where the spacecraft is, you have to put in 7 commands into the computer, and that's way too many for them to do in a short period of time. So instead of that, they said you can enter 1 command into the computer to tell it to change the landing site itself. So if you see you're landing long, just tell it to land short. And that's the way they did it. They came down within a few hundred feet of the Surveyor spacecraft successfully. They toddled over to the spacecraft on their second EVA and cut off pieces of it. One of those pieces is the scoop from Surveyor 3 that was used by the unmanned spacecraft to pick up rocks off the surface. They cut that off. They cut off the TV camera. They brought them back to Earth to examine. And when the people on the ground examined them, they found germs, and they thought, holy mackerel, these germs have survived on the spacecraft for a couple of years on the lunar surface since it touched down back in 1967. All this time they've been sitting on the moon, and they survived in vacuum and radiation and all the rest of it. Well, no later on, they decided that the people in the clean room hadn't been sufficiently clean when they examined the spacecraft, and they had gotten some of their germs on the pieces that were brought back from the moon. So, in fact, no Earth germs did survive on the moon for a couple of years. Now, I think the only other notable thing for me was that I was 13 years old. I had just turned 13 years old, probably the week of the Apollo 12 mission. So I was, with my mother's permission, playing hooky from school to see it. But then just 20 minutes after they got the camera out on the surface of the moon, Al Bean pointed at the sun by mistake. So they lost the picture, and we didn't get to see much of them walking around on the moon. And I remember being very disappointed by that. The mission itself was a fantastic success, particularly for the second one. And maybe no mission more successful in terms of its objectives. And that's all I have for you.
Well, thank you very much, Cliff. That was great.
Joe, before you move on to the next person, I think Claire had something she wanted to say also.
I just wanted to comment that I believe Michael Steniken is responsible in part and later for getting a good set of coordinates for spots on the moon.
Okay, thank you. All right, so now I want to move on to Mr. Blackburn, and let's have you come back on again, unmute yourself, and say a few words for us. And again, give us the benefit of your experience.
Thank you, Joe. Well, I find it interesting when I talk with groups about the Apollo missions, how many of the people described to me how young they were when we were doing these Apollo vehicles. And while most of them were in their diapers, we were building spacecraft at a very unusual rate there in Downey. And from our perspective of the program, these spacecraft were just marvelous pieces of engineering and machines that, when we got the original contract, there was no book of assembly that said, this is how you go build a spaceship to go to the moon. We had to invent that. We had to figure out how to do that. And of course, with the unfortunate accident of Apollo 1, we began to realize that there was a lot to be learned. Many of the audiences that I talk to, I share with them the fact that building machines and accomplishing feats like going to the moon are rooted and based in mistakes, failures. Every day, as engineers, we solve problems. That's what we're about. And you would go to work in the morning and there would be thousands of problems to try and solve. And the good part was the ones that tests that failed the day before, you didn't have to worry about them. You moved on. So by the time we got to Apollo 11 and Apollo 12, we had pretty much figured out the machine and how it was going to work. But it was still the man in the loop that was going to be the most important part of the accomplishment. I think, speaking for myself personally as an engineer in the program, building these spacecraft, and a lot of my colleagues, one of the finest things that ever happened was on Apollo 11 when the crew and Mike Collins made a compliment to us about how wonderful that spacecraft was. Of course, when you're 250,000 miles from home, you really want that machine to work. And I think that, like most people who try to remember where were you when we had the landing, like most, we were glued to the TV trying to understand this accomplishment. But the more important aspect of it for those of us who were actually part of the history in building these machines, it's a case of we never look at the moon in the sky the same way again after we did before the Apollo landings. And each mission, each crew contributed more to quality of life and the way the technology we enjoy today. This past year, with all the presentations and interviews that I've done, one of the realizations that I've shared with folks is that we can't give enough credit to those of you from the greatest generation. When I started working on Apollo, my mentors were the men and women from that greatest generation who came back from the Second World War, and they shared with us younger engineers an attitude a can-do attitude. And that prevailed with our families and everything that we did, so that achieving these accomplishments from Apollo 11, 8, 11, 10, 12, all of them, is something that is a true legacy to future generations. And we think that it's very important to continue to tell this story, the story of the men and the women who built and created the hardware, the men and the women who risked their lives to fly it and achieve these goals. I leave it, and after all of my thoughts and reflections on this, I like to leave my audiences with one thought. If there is a lesson learned and a contribution from our legacy for the future, I suggest and recommend to the children, to the parents, to the families of today, if you want the future of whether we go back to the moon, Mars, or wherever, is not in our hands. We had our day. We had our Camelot. The future is in the hands of our children. And what we need to do is to teach our children to dream. That's how we got to the moon, and that's how we'll get back. Thank you.
Fantastic, Carol. Thank you so much. And, you know, we are obviously here to honor everybody who took part in the Apollo program. And obviously that very much includes you and some other people here today. Let's go on now. I think, Anthony, why don't we go with you next, Anthony? And you can unmute, and why don't you tell us a little bit what you think about Apollo, how important it is to you, and any good stuff like that.
I come at this with a little bit different perspective, you know, and this is part of the perspective I'm going to try to bring into ISDC 2020 next year as well, because I'm the chair of that of ISDC next year. And that is, and also when I write about Apollo, I've written a number of articles at Astra about Apollo from a leadership management perspective. Not as much about the details of the missions as much as what we should, you know, gain and garner from each mission and apply towards today. You know, I've had the opportunity and the great fortune, I should say, of having the ability to get to know a lot of these Apollo astronauts very well, and not just the astronauts, but a lot of the flight controllers and the flight directors, etc. I mean, so much so where I've stayed at a lot of their houses before, so I've got a peek behind the curtain, so to speak. Especially with the two L's, Al Bean and Al Worden. And, you know, Al Bean, to me, kind of gave a different perspective of what going to the moon was like. And some of the things he said to me have always stuck with me. And you have to understand that by trade, right now I'm an educator. I was a former Air Force fighter pilot back in the day, but now I'm an educator. I'm a college provost in Iowa. And I work with young minds every day, trying to inspire them into STEM careers. But I'm also an educational psychologist, and that's what my background is. So I always try to look at the psychological perspective of all kinds of problem solving and how they deal with things. But some of the things that Al Bean said to me, just kind of always kind of stuck with me, because they have to do with a lot of perspective issues when it comes to leaving the Earth and going to another heavenly body outside Earth. You know, one of the things that Al said when he and I were chatting over coffee one morning, he said that when I got to the moon, and when I landed on the moon and I got out and I was walking around, I was looking back at Earth, he goes, we have no idea how good we really have it on the Earth. I mean, we spend so much time bickering and arguing and over petty things, and then just not realizing how good we really have it in the perspective of the universe. And then he said that when I got back to Earth, I never once ever complained about the weather ever again. Now, he lived in Houston, so I mean Houston gets their weather, believe me. And he goes, I never complained about the weather ever again because I was just happy to have it. And that's a perspective that only an Apollo astronaut could have, because we're so used to having weather and bad weather and good weather and all the weather in between that we often complain about the weather. We whine about it because we're spoiled. We don't really understand, appreciate the planet we live on. And it takes a unique perspective getting outside of the planet in order to look at the planet to understand what we have. He also said something else that kind of stuck with me to this day, and this is what I do a lot of writing about, because these are the kind of lessons we need to take to heart. And that is, he realized when he first got to NASA, I mean, he was a test pilot for the Navy. When he first got to NASA, he thought he was going to come in and just be surrounded by super smart people that all knew what they were doing, and it was going to be just, hey, I'm going to jump into this thing, I'm going to fly it. And then he goes, I remember I went to the first big meeting, we sat down, and I realized in about 10 minutes, we were in trouble. Nobody had a clue. And he's sitting there, and we're just like, nobody knows what they're doing here. And it was the process of going from that to watching all of what he called the doers, the people who were doing all of the work, the people who were doing all the math, all the engineering, all the science to make it happen, that was the most important, the most amazing thing to him, far more than actually going to the moon. In fact, he often said that the greatest thing NASA ever did was creating the ability to contingency think, to think about all the problems that could happen, that hopefully won't happen, but they could, and to go through and develop a procedure for every one of those possibilities. And the ability that NASA had to think through that, to elaborate in the abstract, so to speak, mentally, and do all those things, that was NASA's greatest accomplishment of all, because they were able to predetermine problems long in advance that many times saved missions without even realizing it as they were creating the solutions to the problems. So he spends a lot of time focusing on all the people that usually the people that nobody ever gives any credit to or doesn't get much credit to, because they're kind of behind the scenes. They were doing all their little job, their task, their one purpose. They were doing all the things that they were supposed to do as part of the job, but they weren't on the forefront. They weren't getting all the press, and he puts a lot of accolades into those people, and he always has, as long as I've known him. He's a class guy, and he always thought they were far more important than what he did. So, and of course, I discussed that with a lot of the Apollo astronauts. They all say the same thing, but in different ways. But Al did it with certain grace. Al did it with certain humbleness that I haven't heard from the others. And I mean, he even calls himself. It's been mentioned before, but he's even often calls himself, I'm an artist that happened to be an astronaut, because his art was his real passion, and having gone to space was great and cool and everything for him, but his real passion was art. And it just shows how, despite the great thing he did, he's still a very humble guy about it, and he just that says a lot about him as a person as well as an astronaut. The problem that I see today, and the reason why we need to keep talking about Apollo, is, unfortunately, as an educator, and I'm seeing a very sad shift happening in education today. Where, well, here I'll tell you, there's a recent study that was done that shows that at the time of the Apollo launches, there were about 5% of the people out there who did not believe we actually went to the moon while it was happening. About 5%. There are always the conspiracy theorists out there. Unfortunately, that has risen to a most recent number showing about almost 30 to 35% now believe that, which is unheard of to me, unbelievable to me, but about a third. And it's mostly in young people. And that's because young people weren't around. Young people just have no connection to it whatsoever. These are the same people that utilize technology today that often, but much of which came out of the Apollo program, but they utilize the technology today. Don't give it a thought of where it came from. They just assume it was always there. And they believe this conspiracy theorist concept. They saw some video on YouTube or whatever. And I think it is our task, our mandate as people who are a little bit older, to constantly wave this flag and talk about the greatness that was. Someone earlier mentioned the greatest generation, the World War II. that's something else that's fading away here pretty fast too. The perspective and the understanding of what it took to win the World War. And, you know, as we get further and further away from something, you know, in history, it fades. And this is something that can't fade, especially if we're trying to inspire a generation. You know, Gene Cernan once told me that, you know, I asked him point blank, I said, Gene, what is the most important, the one thing about your career you're the most proud of? And I honestly thought he'd say, well, walking on the moon has to be towards the top. No, Gene's first thing out of his mouth, and he did not hesitate, was, I am most proud of the fact that I was part of something that inspired an entire generation to go into science, technology, you know, engineering, and math. An entire generation to do that, which he did. That was my generation. And that is not there anymore. There is nothing out there today that's inspiring our entire generations of kids anymore to do something like this. And that's what's missing. And that's why we have to keep doing this and keep talking about Apollo. And I know that there are some people on NSS who think, oh, let's talk future. Let's not get into the past so much. You know, Apollo's great. It's wonderful. It happened. Let's talk about all the cool stuff in the future. And I'm not trying to take anything away whatsoever from what Elon and Jeff and all the other ones are doing out there at SpaceX and Blue Origin. But I will tell you that what they're doing, despite how cool it is, it still doesn't measure up anywhere close to what we did with Apollo in the 60s at all. And I can give 1,000 reasons why that is true. So we got to make sure we keep talking about it and we keep telling the stories to young people and show them. And this last year was a good year because it was the 50th anniversary. My fear is that's going to fade. You know, Apollo 12 has happened and launched last week, and you know we're celebrating that right now. But you're not hearing much about it in the press right now, or anything for that matter, like you did Apollo 11 and Apollo 13. We might hear a little bit about because of the movie. Apollo 14 and 15, and you know 16 won't have much anything probably attached to those either. We might hear about Apollo 17 a little bit just because it's the last time. But we got to keep talking about it. We got to keep sharing these stories, and we got to keep learning from the past in order to make the future happen. Because the future will only happen if we can learn from the past. So that's my primary take on this. I tend to come at it from a more psychological perspective. I will tell you that one of the things we're going to do at ISDC is we're going to look at how science, I'm going to run a track called Science Fiction to Fact, talk about what we can learn from science fiction to help us make the future happen, and also how science fiction inspired people to make things happen. A whole panel of engineers will be on that panel as well. But if you think about it, Apollo was science fiction the decades prior to it happening. So it's important we keep the imagination flowing. It's important to keep people engaged.
All right. Well, thank you, Anthony, very much. Appreciate that wonderful discussion. And you're absolutely right on. Totally couldn't agree more. I saw an article, I got to tell you, about a week ago, the Flat Earth Society and how it is in a renaissance. That should scare everybody on this call. The Flat Earth Society is having a renaissance. All right? People that do not believe the earth is round. Shocking. All right. Thank you. And last but far from least, Lawrence, why don't you come on in? We're going to go a little over the 7 o'clock period, obviously, so let's just stick with it, but we want to hear all these people out, okay? So Lawrence, you come on, unmute yourself, and you got the floor.
Okay, can you see me?
Yes, we can.
Oh, okay. Well, guess I'm pretty lucky. I give a lot of talks on this topic since I was one of the few people who were sitting there in mission control when all these things happened. There are 400,000 people who worked on Apollo, and the night of Apollo 11, there were like 3.5 billion people watching on TV, I like to say. And less than 100 were in mission control, and how I ended up there is a whole story. I've written books about it. It's pretty miraculous, but it has to do with your putting yourself out there and resisting the effect to let failure and disappointment change your life. I call this, one of the talks I give is called the 4 Ps, which stands for passion, priorities, persistence, and putting yourself out there. So that's kind of how it ended up for me. I mean, I had a lot of things that could have gone a lot different directions, but because I really wanted to be part of this program. I made it a priority, and I didn't let disappointments get in the way. I ended up in that position. Enough about myself. I got to Johnson Space Center. I was, let's say, 21 or 22. A few of you have talked about how young everybody was. We didn't know it then, but everybody was really young. My first experience with Alan Bean, I'm going to show you this photo. Some of you may have seen it. Let's see if I can get this to show. Let's see, can all of you see this? It's on my iPad. I'm trying to do it to a.
Yeah, we can see it.
So there's Al washing his brand new Corvette with his buddies. Can you all see that?
Yes, we can.
So he was quite a. They were a cut-up crew compared to Apollo 11. They were much more businesslike than Apollo 11. So in later years, I got to know Al's wife, Sue, and Barbara Cernan very well. In fact, the three of us just got back from a few months ago, got back from a cruise on the Queen Mary 2, where we give lectures and talks about our experiences. And if you're interested in seeing those, they're live on video. If you Google Apollo Palooza, that's Apollo Palooza, APOLLOPALOOZA. You can see these talks about what we actually did, and they're very entertaining. The two girls talk together, Sue and Barbara, about their husbands, and you'll get some insights into Al and Gene Cernan, who I got to know in a different way when we were trying to save the space shuttle towards the end of the space shuttle program. But yeah, fascinating insights into what it was like to be the wife of an Apollo astronaut. So I highly recommend you go to those and look at it. But as far as myself, kind of a funny story. I don't know how much time I have here, so why don't you let me know so I can kind of
just go for it. If people have to drop off, they will.
Yeah, so it's interesting. I started out, my dad had a clothing business in New York, in Manhattan. And I used to help him out during the summer. And he ran into some problems. And one day he called me over and said, whatever you do, I don't want you to have anything to do with the schmata business. So in New York, the schmata business is a fashion business. It's the clothing business, the 7th Avenue fashion, where they make all these dresses. And he just kept saying, don't ever have anything to do that. And it was so funny because a couple of years later, when I got accepted by NASA, I ended up going over to Building 7, which is Crew Systems Division, and I walked in the door. I didn't know what I was going to do, and they said, "You're going to help design spacesuits." I got a real laugh out of that because, of course, a spacesuit is the most complex schmata ever made. But at that time, I knew nothing. I mean, zero about the space program. I'm like a 21-year-old kid, just graduated. And so I was told to try to model the human body in a very simple mathematical model. And didn't know much about that either. Everything myself, as other of you guys have mentioned, you learn most of it on the job. I didn't learn I learned mostly how to think at the universities, but certainly very little about space program. And so I kind of built this thing called 41 node man. The 41 node man is a math model of the human body, complete with fat core, muscle, and skin layers, and it has a blood flow system, and it has a thermoregulatory system. Sounds a lot more complicated than it is. For a heat transfer person, graduate heat transfer person, 41 nodes is nothing in today's world. And but it was, I like to say that good is the enemy, best is the enemy of better, which is the enemy of good. And it was good enough. It was good enough to give a rough idea about how the human body produces heat and sweat and comfort, and you can assess comfort with it. And around that, I was able to build a spacesuit, including a liquid cooling garment. And these are very simple models, but like I say, they were good enough. In fact, they're good enough so that they're still being used by NASA today. They're embedded in lots of different models that NASA uses, thermal models that predict what the human body does to the spacecraft and the interior and the spacesuit and vice versa. So it doesn't have to be perfect, just has to be good enough. And what happened then was over in Mission Control, they were looking for ways to determine how the consumables in the spacesuit were being used real time, because we didn't have a gas gauge and we still don't. We didn't have a gas gauge on the spacesuits that told us how much life support was remaining. It was a critical item. So we had to predict it using different methods. And one of those methods, the one that turned out to be the most accurate, was assessing how much heat was being pumped into the liquid cooled garment. And when you know how much heat's being pumped into the liquid cooled garment, you can back out the metabolic rate. And once you know the metabolic rate, you know basically 80% of the load on the life support system and the consumables that powered the spacesuit, and that enabled you to know your bingo mark when you were going to run out of life support, and essentially that managed the entire EVA, because that told us how much time to spend at each particular point in the EVA, all the different craters and at the Surveyor and at Sharp Crater, all these different places, because you needed to know how much time you had left, obviously, and when you were going to get back to the LEM. And so this was pretty interesting. And when I started working on this kind of thing, I had no idea it would lead to Mission Control. Mission Control, back in those days and today even, is a separate organization that's under flight operations. And I was working in Crew Systems Division, which was it was a research R&D and most of us never really would get into Mission Control to work on real-time operations. We kind of supported those guys. But what happened is my boss, his name was Walt Guy at the time, he went over to Mission Control and he said, we have a way of figuring out how much life support you've got left with this 41 node man model. And they said, well, that's okay, we don't need that. We've got our own guys doing it. And I guess Walt persisted, because we ended up having like a contest over in the CECL, the Space Environment Simulation Chamber. We had a contest where we put astronauts in a suit, and we had them go through their paces in a vacuum with a overhead sun beating down on them that was simulated with these gigantic xenon lamps. And we ran them for a certain amount of time. When they got back out of CECL, we measured how much life support they had left and how much had been predicted. And I guess I was pretty fortunate, because 41 node man little model predicted it pretty much right on the money, and it was better than the one that was developed at Mission Control. So the decision was made to use 41 node man and me with it. And otherwise, I never would have gotten into Mission Control in a gazillion years. It was just fortuitous. So my job was to support the EVA console and the surgeon console. And I was right next door to them in what was called the Life Support SSR, the Life Support Staff Support Rooms, just about 5 steps across the hall into the MOCR. And I remember this happened in Apollo 11 and Apollo 12, of course. You're sitting at a console, you've got a screen. It's not networked. Today's all the screens are networked, but your console was basically getting a piece of the data that nobody else got. And I just remember sitting there, and all of a sudden, everything starts coming to life during Apollo 12, Apollo 11 at first, and that was sort of miraculous. So in my particular case, the most important thing was where we going to get liquid cooled garment data coming back, oxygen data, and heart rate data, because those were the key physiological parameters. There was a whole other set of parameters about suit performance, but the most important ones in terms of determining life support use real time and life support remaining when I say life support, it's the amount of feed water left in the portable life support system that drove all the thermal control systems. The amount of oxygen obviously is critical, and the heart rate, which was determining a lot of physiological stress that the surgeons were using. So each one, there were 3 of us sitting there in console looking at all this data. We had a flight surgeon right in back of us, and he would look at the data, and then we would simply report it to the EVA console and the flight surgeon every 6 minutes. That was our job. Right next to me was a EKG strip chart. And Alan Bean's EKG and Pete Conrad's EKG were writing real time on a strip chart that pretty much exactly the same EKG chart you see when you go to get a cardiologist to get a stress test. And that thing is rolling and rolling. At the end of the EVA, I cut off a little piece of it. I have a 1 foot square section of Apollo 11 and 1 foot square section of Apollo 12. They're signed, and they're worth something. The funny thing about Apollo 12 is I didn't get Al Bean to sign his until like 30 years later. And I called up Al and said, Al, can you sign this strip chart for me? He says, that'll be $50, young man. I practically choked. And the reason for that was Al was an accomplished artist. He didn't want to get it. He wanted traceability of it. And a couple of months ago, I spoke to Sue, his wife, about this. And he said, yeah, that was Al. Normally, he wouldn't have done that, but he'd gotten in this mode where he was wanting to become an artist, and he wanted to think everything that he did was worth something. So I sent it over to his house. He signed it and got it back to me. It's sitting in my closet just a few feet away right now. Speaking of which, I don't know if you can see this. I like to show this as well. Let me show this. I don't know if you guys can see that, but that's, everybody see that? Maybe you can see it here. Is that a better shot?
Yeah. Spacesuit. Looks like a suit.
So that's, yeah, that's the liquid cooled garment that Buzz Aldrin wore. Not on the moon, obviously. That was left. That was his training liquid cooled garment. And I used that to do my PhD here at Berkeley. So it was good enough to get that. So I know quite a bit about these liquid cooled garments and how they work. And so back to the data. So you're sitting on console, and all of a sudden, data from that liquid cooled garment starts coming back, and the other parameters of the suit. So we integrated all that, and every 6 minutes we're sending that over to EVA console and the surgeon. And that's basically how we manage the EVA. Every single point, we use that to determine not only how much life support was being used, but how hard tasks were on the lunar surface. So we knew pretty much how hard it took to go into, to set up the flag, how hard it took to set up the owl step. We knew when they were going over to the surveyor, what was going on with the surveyor in terms of reaching in and taking parts about it. We knew what the energy it took to walk on a flat surface, the energy it took to walk down the inclines and up. And we're able to relate 1.6G to 1G. And later on, we were able to, in a later life, we were able to relate that to predict how hard you'd have to work on Mars as well. So all this data was courtesy of this little 41 node model and its supporting models that it worked with. All that stuff is being used today actively at the Johnson Space Center to determine the best suit designs. And you need to know this, because if you're going to send somebody out for 7 or 8 hours at a time, you need a very good handle on how hard it is to work and do tasks. In addition to obviously wanting to know how fast you're using up your life support. And our spacesuits have not changed very much since, some of you may know it, since the Apollo era. In fact, they've gone down quite a few ticks because you can't walk in a current spacesuit. You can't walk in an ISS spacesuit. You couldn't walk in a shuttle spacesuit. The lower body ambulatory features are all gone. They're designed for upper body movement. In fact, I've often thought a paraplegic is probably a better astronaut than a regular person, because they don't use their legs, and they have much more skills in their upper body. But we're going back to the moon, and we're going to go on to Mars, and so those designs are going to change. I'm currently working on a Mars spacesuit design, which has to be radically different. It's got to be 1/3 the weight for a whole variety of reasons. It doesn't look anything like these suits. But these suits were cumbersome. They're a lot more bulletproof than people thought. In the beginning, we were heart-stopping issues with literally every minute. Apollo 11, our objective was to just get out there, pick up some samples, and get back in. And I can tell you, having lived through every second of it, just what a stressful mission that was, from launch until landing. I'd like to call it waves of emotion that kept on peaking. Were they going to get off the ground? Were they going to get to the vicinity of the moon? Were they going to be able to land? If they landed, were they going to be able to get off? Were the systems going to work? In my particular case, was the data going to come back from the bioharness and the PLIS? And then were they going to be able to launch back off the surface of the moon? And finally, were they going to be able to land? These are all like stress levels you cannot imagine when you're sitting there with less than probably 50 total guys wondering if all this is going to happen and they're going to make it back. And so you can imagine during Apollo 11, the idea was to get them out, check out that the suit worked, and then get them back in. And so when Buzz starts running around like a crazy guy doing football stops and all that stuff, everybody's heart's in their mouth. And that's just one more piece of the pie where people's heart was in their mouth. You really can't, what the hell is this guy doing? Just pick up some samples, put the flag, show the thing works, and get back in. It was 2 hours, and if I remember, 2 hours and 15 minutes, 2 hours and 20 minutes. But all that helped us realize that the system was stronger than we thought or we imagined, and we got confidence that by the time Apollo 12, which was 2 EVAs, they were not as as heart-stopping a situation as we originally thought. So, from my perspective, I'm looking at a screen and I'm looking at the TV images coming back to mission control, and taking it all in. EVA 1 was more or less setting up, stepping on the surface, setting up the flag, setting up the ALSEP, and setting up the solar wind experiment and things like that. And EVA 2, where they traversed a lot longer area, was going over to Sharp Crater and the other different craters, and going over to Surveyor, bringing back a sample and getting back in. And then launching back to Earth and coming back in, getting picked up by the Hornet, where my roommate was inside the inside the Airstream trailer. And it was Randy Stone, who then became a director of mission operations at Johnson Space Center. So Randy Stone was the chief cook and bottle washer. I was really lucky because I had 2 roommates. One of them was John Hirosaki. He was the chief cook and bottle washer for Apollo 11, where it was basically Neil and Buzz and John inside the MQF, the mobile quarantine facility, and Apollo 12. Randy, my other roommate, was in there with them. So those guys spent 2 weeks with Apollo 11 astronauts and 2 weeks with Apollo 12, basically taking care of them and cooking for them and providing for them. So that was my experience during Apollo 11 and 12. Did the same thing during 13, 14, 15, 16, and 17. Of course, I didn't have a job during 13. some of you talked about the education value and the fact that we don't do those kinds of things today in a lot of ways. In a lot of ways, you're right. In a lot of ways, you're not right, because giving a lot of lectures and teaching undergraduates at different universities as I have through the years, there's just as much enthusiasm for this kind of thing. And to be part of it as an engineer or a scientist or a physiologist or even a spelunker, somebody who goes through caves. I mean, there's so many different professions involved in this kind of thing, photography, that whenever I give talks anyway, it's a pretty large audience, pretty large diverse audience, a lot of kids who are enthused about this. But I can tell you this, they're much more enthused about Mars than they are about returning to the moon. And so am I. I think the return to the moon is I've written about it, and some of you may disagree. I think it's a diversion that's going to cost us 20 years at the minimum before we get to Mars, which is, after all, the only place humanity can survive besides planet Earth. We can't survive long term. Mars has got everything you need to survive. Tough life, yes, but it's survivable. We know how to do it. We know far more about Mars today than we ever knew about the moon prior to Apollo missions. I mean, so much more, it's ridiculous, because I knew how much we didn't know prior to Apollo 11, and that was the tip of the iceberg. I mean, we knew enough to make it work, but we know much more about Mars and how to make it work for survivability. So when I hear about what's going on with crash landing program to get to the moon on 2024, by 2024, it kind of makes me tinge a little bit, because I really think it's misguided, misdirected. And one other gentleman who talked before mentioned this can-do attitude. And yeah, we had a can-do attitude. We honestly believed we could do this, despite the fact that we didn't know how much we didn't know, you know. And we really believed we could do this, anything. And that attitude, as I hung around NASA until 2014. So I saw a lot of programs, and I was part of the team to help build the space shuttle, and was a life science manager in ISS for the Human Life Science Experiment. So I got to see quite a bit, and I've written about it in a book called Save the Shuttle. If anybody's interested, you can find it on Amazon. So all these experiences are chronicled in quite in depth. But one thing I wanted to communicate is that by the time I left, this can-do attitude that we had in the beginning had changed, and there was a lot of bureaucracy. And NASA grew from a smaller agency to a much larger bureaucratic agency. And in the beginning, I really did not welcome or think that the commercial space industry, as it was beginning to bubble up, would have much of an impact. And I kind of poo-pooed it, because you grow up with NASA, and it's kind of a not invented here mentality. If it's not invented here, we don't do it here, then yeah, you know, it's okay, but it's not going to be what we do. And by the time I left, I completely changed my mind, and I kind of switched gears. I really thought that the creativity, the interest, the diversity, the way to save money coming in from SpaceX and other folks like SpaceX was, they're the ones with the can-do attitude. NASA had become too bureaucratic. And that's why I have a lot of belief that if we do get to Mars, it's going to be SpaceX or somebody like SpaceX that's going to do it first. And they're going to do it better and cheaper. I don't have a whole lot of, faith is not the right word. I'm sure the Space Launch System is going to get off the ground. But when you take something of the complexity and the push it to the limit design of the shuttle main engines, and you stack it with a system that the Space Launch System is, and you got to remember the space shuttle. And I was on the floor of the OPF building the space shuttle, building Columbia. So I got to know Columbia pretty well. This was a vehicle that was created and envisioned to be reusable. And a lot of components were reusable. And it still was a very expensive vehicle to operate, but it was in large measure reusable. And now you've taken all those components, you've put it in a space launch system, you're going to drop everything into the drink, including those amazing engines that are not going to be reused. And you're going to compare that to a design coming out of SpaceX where everything, including the core stage, is going to be relanded. How do you make a comparison? I mean, there is no comparison. And when you get to know how these things work, you realize a lot of NASA is political. And back in the day of Apollo, I was so fortunate, amazingly fortunate to be part of all these programs. Apollo, we had a blank check. We had a blank check because of a confluence of events that'll probably never happen again, because we were involved in a Cold War, and because JFK said, we're going to go to the moon, we're going to do it within the decade. We did it like 8 years, or we could have done it in less than that if you throw out the Apollo 1 mistakes that we made. We could write checks to basically do whatever the heck we wanted to do. That's not around anymore. You can't write checks. You're a whipsaw. NASA is a whipsaw of politics. Every 4 years, a different administration comes in. Every single year, the budget has changed. So if you're building hardware, try to stick on a schedule when your budget changes every single year and you have to justify your existence, which is what we have to do right now. We had to do it back then, but at least then we had a blank check. I've watched more Mars plans, Mars mission schedules, Mars mission plans come and go than you can shake a stick at. Back when I was working Apollo, I saw Mars mission plans be tossed in the trash can. We had to put out, in order to keep our offices clean, we had to take all the data stuff we weren't going to use and put them outside in a pile that were collected and sent out to the trash containers. And every year there would be Mars mission plans. This is starting back in 1969, 1970. So I've watched us get pretty close. I watched us get close with the Space Exploration Initiative. Watched us got close with Constellation. Now I'm watching us get close with Space Launch System, and what we're doing now. And we're probably getting a little bit closer because there's more money and stuff like that. But I have a lot of reservations about where these programs go when NASA does it these days. And I can look back fondly. One of you guys said every time you look up at the moon, you know, life is different. You know, I mean, I can still remember getting out of bed about 10 o'clock at night in Houston, driving a mile over the Johnson Space Center, parking Mission Control. I had a special bag sitting there on this, sitting on this spacesuit right up there. You can see that. Up at the top underneath the helmet, you can see a series of pink badges. I don't know if you can see those pink badges sitting there. And you can see another one that says 11. I don't know if you can see that. But that was a very special badge. Very few of us got issued that badge. So I put that badge on as I'm walking across the parking lot. And the last thing I did before opening up that door to go into Mission Control was look up at the moon. And it was a crescent moon. And the Terminator was right pretty much smack dab where Apollo 11 had landed. And that was the first time, you work hard on these things, the first time I realized what was going on, and I got goosebumps, man, I can tell you that. And you realize you're part of history, and that kind of feeling will never come again. And every so often I look up and get that same feeling. I know what's there. I know what everybody involved, 400,000 of us, did to get us to that point. And I wonder if we're going to get back. So I look at it and I say, you know, that's a wonderful thing. But then I shift my gaze when I can to Mars, and that's where I think we ought to be going. And I've probably talked longer than I should have. Said a lot of things. Last thing I'll say is that I've got a lot of belief in the education systems today. There's all kinds of courses about Mars, about spacesuit design, about engineering and what it takes to get into space and spacecraft design, propulsion system, going on all different levels, including undergraduate levels. We have a different way of teaching that's starting to build up steam, where different universities talk to each other. It's not just a simple class, it's interdisciplinary. And this is a growth phase for us. We tend to look at our lives as if we're the be all and the end all, and the technology. And you've heard some of my complaints about this and some about complaints about NASA back in the day and today and stuff like that. What you don't realize is that the pace of technology is through the roof. We're in a discontinuity right now. We're in a singularity. We're not in a straight line. We're not in a straight line slope. We're not on an asymptote. We're not on an exponential growth of technology. We're in a discontinuity. That's how fast the pace of technology is. So if we look at our time in our life and our lifespan, we tend to look at it through our eyes. It's the wrong way to look at it. You got to look at it like back in 1900, there wasn't an airplane. And here, 115 years later, we're talking about going to Mars. We're talking about self-driving cars. We're talking about artificial intelligence. We're talking about curing cancer. We're talking about sending little nano machines into the bloodstream. I just went to a conference 2 weeks ago where we're talking about and getting a handle on something called POH140, which activates the genes that suppresses regeneration of limbs and organs in the body. It's been demonstrated that mice can regrow tissues and cardiac tissue and arms and legs using this POH140. We're talking about being able to look inside the human body, look inside the human brain, and bypass obstacles that prevent us, that can cure people who are quadriplegics and paraplegics. We're talking about being able to bypass Parkinson's and depression. These are real things that are happening in our lifetimes as we speak. So the pace of technology, again, it's a singularity. It's not even to be believed. That's how miraculous all this stuff is. So you'll forgive me for sitting there and waxing how we didn't do things today the way we did it during Apollo. The truth is we're doing it a hell of a lot better by leaps and bounds. So I just wanted to put that in perspective, including the ability to go to get to far-reaching parts of the universe that we had no idea. So don't know if you guys got any questions. That's a mouthful, and that's about all I can say without spending another hour blabbing on. So thanks for letting me have the opportunity to chat with you.
Well, thank you. Thanks. And so if you're still with us and you don't have the interactive capability, remember that down on the bottom there's a Q&A button. You can click that and you can type in a question. Now there have been some questions from folks that were asked and answered by other people. Basically 2 questions. One was, who will own the resources on the moon? And Randy Gigante answered, whoever mines it first. And then the same person, Michelle Forfoy, I can't read this, I'm sorry, Forroy, add to my prior question. Due to the Apollo program and landing on the moon, do we have any right to claim the resources on the moon? And Perry Dutre actually has a link in here, which I can't read it out to you, which talks about NASA's position on the preservation of lunar historical sites. The whole question of ownership in space is one that actually the chapter's assembly is getting around to asking and hopefully creating a resolution on in the not too distant future. Just for those who don't know, the chapter's assembly has been reinvigorated of late. We redid our charter, we redid our bylaws, took a lot of effort, and now we're very much more proactive than we've ever been. We actually have a resolution that's out that has just been seen by National Space Society leadership. And this is something you folks don't know. The National Space Society leadership has given a green light for us to publish that resolution in the next, not this next issue, but I believe the one after that issue of Ad Astra. So our resolution that we worked so hard to develop, where basically we say that we are supporting the idea of getting back to the moon as soon as possible. However, we believe that it needs to be both a permanent return and a sustainable return. And that's the key phrase, sustainable. I believe that Lawrence probably would go for that. I understand going to Mars and I understand his point of view that Mars pretty much, other than the Earth, has got an awful lot of what will sustain a populace. But the moon has got the benefit of being quite close to us. We will live on the moon underground, just like we will live on on Mars underground. We cannot abide the cosmic radiation on Mars or on the moon. So the moon is a great proving ground for us to build the kind of sustainable and permanent systems that we will need on Mars. And so, of course, that's why the chapter's assembly almost unanimously voted in favor of this resolution that, as you know, as you now know, is going to be published soon in Ad Astra. And while it won't be policy of the National Space Society in giving us the green light, what they're basically saying is that they appreciate the chapter's assembly having evolved this resolution, and that they believe it's important enough that it should see the light of day above and beyond their own being told about it. So pretty excited about that. Almost excited as I am about this meeting tonight and how wonderfully it's gone. Now, before, can people, I'm on. Before I leave my chapter, we have a few members left here, but we also have a little memento back here. We have JP Aerospace, as I mentioned, does stuff with balloons, including what they call rockoons, and that is rockets that are launched through balloons. And on this rockoon, you'll see the signature of Richard Gordon right there. And
Jose Hernandez, our friend, astronaut from Stockton, is above it. So
right.
Once he saw that Richard Gordon had signed it, Jose had to sign it.
So anyway, we have a little bit of a memento here. Just thought we'd share that. And so we're a small chapter, but one of the things we are is inventive and creative. We've been doing virtual stuff probably longer than most anybody else in a National Space Society. We have one member who isn't here tonight, this morning rather, who has been virtually present for, I would say, the last 8 years, one way or another. So this whole meeting tonight, this whole virtual presence is something we've been trying to look at and develop for quite a long time. And I'm very gratified to see the support that showed up tonight. Let me just quickly introduce people. Why don't you introduce yourselves?
Isn't it morning, Joe?
I'm sorry, morning. I've lost all track of time.
In India, it's night.
We're used to being here in the evening. But this is, introduce yourself. Speak loud. Speak loudly.
I am Paul Turner. I wrote the Space Trade and the Space Trade Update. And I think I've found a way for the investors to be interested in space, moving us from the politics into the private sector.
Okay. And this is?
Jan Rofton. I'm just a space enthusiast, no background in it, but
I've always loved it and wanted to see it happen.
And Tom?
So Thomas Tolan, I've worked in the space industry, primarily satellites, for 30 years, but have always been interested in this. But I was only 9 years old when actually 7 years old when Apollo's did all its stuff. So I didn't really recognize it growing up, but it's nice getting involved with the people that did.
Right.
So thank you.
And a gentleman that is not here, he had to leave, Eric James. Eric worked on the LIGO, which is the instrument that detected gravity waves. And so he helped on the instrumentation on that, and he was here briefly. And others of our group of like kind, and a lot of people that are, like I said, creative thinkers. So if you get a chance, our website, Sacramento L5 Society, is sacl5.org, SACL5.org, and check us out. Anyway, I would like to quickly go down the list if people either would like to ask a question. Let's see. As near as I can tell, there is one more question. Matthew, and this is from the group of people that cannot be seen or heard from, but that are out there as non-participatory. To anyone, it seems that the 2.5-year mission time to Mars and back subjects the astronauts to way too much risk. What are your feelings regarding reducing this mission time to something like 1 to 1.5 years? This, in my mind, should be a high priority. So, anybody have an answer to that or a thought about that?
Yeah, I'd like to answer that.
Go ahead.
Okay, I've done a lot of Mars mission analysis and also being part of the life science community. I was responsible for 43 human life science experiments on the International Space Station that are still being conducted today that have to do with answering this kind of question. And basically, the outbound leg to Mars is 6 to 8 months. We've lived on ISS longer than that. We're able to return to Earth and function during landings with very little. We have countermeasures to almost every physiological issue that has come up. There are some recent issues with stagnating blood flow, but for the most part, muscle loss, even bone loss, neurovestibular, all of these concerns have been mitigated with countermeasures. We have a lot of confidence that the outbound leg to Mars is achievable very well. Then we land on the surface of Mars, which has 38% of gravity. It doesn't have 16% of gravity like the moon. It has 38% of gravity. So what does that mean? Well, that means there's a darn good chance that living on the surface of Mars is going to correct or prevent any additional changes in our physiology in a negative way. So in all likelihood, we're going to be on balance and not losing bone mass and not losing muscle mass. And even if that was a possibility, you can be certain that the habitats that will be pre-landed will have the same countermeasure facilities that the ISS has. And so now you have a return leg after a year and a half on the surface of 6 to 8 months, again, using the same countermeasures that are in ISS. So there really are no concerns, great concerns. I call them showstoppers on a human mission to Mars in terms of physiology. There are some questions about the radiation loads, but we know that we've already done the predictions. We've already looked at what the radiation environment is on a 3-year Mars mission. And just so you know, it would increase the probability of cancer during your lifetime of something between 1 and 10%. It's called a career mission. So those astronauts who would go to Mars on a 1 year and return, a 3 year and including a return mission, that would be their career mission. We're coming up with better and better ways to mitigate this.
Thank you very much. That's a great overview. I want to kind of get other people's feedback as well. So one of them is from Paul behind me. So
I've got a question on the effects of on the ISS, the difference between the effects of weightlessness and the effects of a very high carbon dioxide environment. I think one of the Kelly astronauts spoke of it. How much of the effects that we're seeing on the physiology is from the high carbon dioxide atmosphere, and how much is it from weightlessness?
Yeah, I haven't read any papers on the deleterious effects of high CO2 at ISS. In fact, I'm not even aware of it. It would be shocking to see the life support system go so awry on ISS to have high CO2 in the interior to ISS. I'm not aware of this issue you're discussing.
Okay,
thank you.
Thanks. Anybody else? Anybody else want to speak to the question that was posed by Matthew regarding this mission to Mars? Personally, my own personal recommendation is that while you might have theory about cosmic radiation, we don't actually have any biology about it. I would like to see either the moon or the Gateway Project put some animals out there and get some testing done to make sure before we actually send humans into harm's way or potential harm's way, what the real world is going to tell us about that cosmic radiation. The other issue is, of course, solar flares. What about a solar flare hitting just at the wrong time, and especially if it's aimed right at, by coincidence, the craft itself? How do we, so there are some issues, some I think we can't paper over regarding a long trip in outside of our magnetic protective shield that we have around the Earth and even in low Earth orbit. Okay, so we have Tom here who would also like to make a comment at our chapter. So I'm going to go ahead, Tom.
Well, in terms of the radiation issues, we have a lot of data from other non-biological probes out into interplanetary space, and this goes towards the can-do attitude that Lawrence Coos was talking about. You do your modeling to the best you can, you mitigate the risk to the best you can, and then you just do it. Throwing other things out there will always leave uncertainties. You will never have 100% certainty in your models until you've done it with humans, because every animal behaves slightly different than humans. We can get closer and closer. You put monkeys out there, then yes, but rats.
Oh, we have another question, sorry. Deborah Pollock, slightly less scientific. Did they really have to hypnotize Pete Conrad to keep him from swearing on the moon, given his highly unusual humming? Anybody know the answer to that one?
He said whoopee on the moon.
Okay, we know that the astronauts were definitely, after Apollo 11, were definitely advised to watch the language. When something happened on the moon, I believe, for Apollo 11, and it was a live mic. Anyway, that's the past. So my remaining people who are out there, if you have anything you'd like to add, or questions you'd like to make, this is the time.
Yeah, listen, I'd like to just like to finish up with another editorial about this, because I believe this so passionately that we're about to make a big mistake. And I just want to summarize very quickly why, because I've written an editorial about this, about to send it in. Gabriella over there has a copy of it if you want to see it, but I just want to summarize a couple of points. And of course, you're welcome to disagree. That's what it's all about. But let me tell you about the moon versus Mars. One gentleman who just spoke said, yeah, you just, at some point, you just got to do it. You realize how much you know and how much you don't know. And I will emphasize again, how much less we knew about the moon when we went than we know about Mars today. So let me hit on a couple of checkpoints. Politically, this could cause another Cold War. We have no agreement with China. The moon is so close. The moon is a point at which you can look down on the Earth, you can spy on the Earth, and you can create weapons on the Earth. If you really want to do this, because the moon is so close, and it is a place that lends itself to military participation, let the Space Force do it. We got a new Space Force. That's not the purview of NASA. NASA is a civilian space agency, understand this, dedicated to peaceful exploration and research. It should have nothing whatsoever to do with the potential development of a military capability. That's where this is headed. That's just point one. Point two, species preservation. Mars is the only backup where humanity can perpetually settle. It has every element there for us to build a biosphere in which we can settle. It has all the resources. You can grow plants and crops in that soil. You can make oxygen. It's already in the water vapor in the air. You can, yes, there are some of these things you can do on the moon, but you got to go through hell to do it at billions of dollars. People talk like a chunk of ice at the bottom of a crater on the South Pole is going to be rocket fuel and oxygen, right? Well, first of all, we haven't detected ice. We've detected neutrons and hydrogen. We don't even know that it's ice, but even if it was ice, imagine getting to the bottom of Shackleton Crater, digging up ice and using it with machines that we have to get down there and all the other stuff to make the stuff needed for human life support. That's billions and billions of dollars. And that doesn't take account for the fact that from a human standpoint, environmentally, this is really a bad place for sustained operations. The days last 2 weeks, the nights last 2 weeks. There are no seasons. Without a heavy spacesuit, temperatures will boil and freeze you at the same time. I'm talking about a heavy spacesuit. You need a 350-pound plus spacesuit to operate on the moon. You need a 150-pound spacesuit to operate on Mars. Imagine walking around all day with those two spacesuits. Just think about that for a minute. Mars has days that are 24 hours and 39 minutes. There are seasons. Gravity, sunlight is almost 40%. The temperatures can reach 80 degrees at the equator, and the list goes on, right? You want to sustain humans on the moon? It's going to cost you through the roof. It's going to cost you so much money to do this. On Mars, you can use the Bosch-Sabatier reactions, which is 19th century technology to generate everything you need. Let's talk about training. I'm almost done, so I have to get this in because this is eating my craw and you're the proper audience to hear it. Counterintuitively, a Mars program is actually going to be cheaper because we can survive there without perpetual and costly and frequent resupply. And let's put this together with how we're going to get to the moon versus how we're going to get to Mars. You know, NASA intends to use 3 test flights of a non-reusable and estimated $2 billion per mission SLS, Space Launch System, to get somebody on the moon by 2024. It's still being built. It has yet to fly. During Apollo, we had 5 unmanned test flights of the Saturn 1B and Saturn V, and we took 8 years to do it. And now we're talking about landing on 2024 timeline. SLS, I hate to say this, is an accident waiting to happen. SpaceX's reusable Starship program is way ahead of SLS already. It's already had demonstrated flights. And lastly, let me talk about education. I've taught many, many classes over the years. And when you get students in a classroom, there is no comparison. There is no comparison whatsoever in kids who are interested in the moon versus Mars. So you can talk the moon all you want, but I've been living this for a long time, right? And as far as using a gateway, well, why would you want to put a gateway on the moon in order to get to Mars? If that's your reason for building a gateway, that's crazy. You could build a Mars vehicle on ISS. You could send spacecraft from the Earth. You want to go all the way to the moon to build a gateway so that you can get to Mars. Or you want to do it from the moon. You want to build a launch facility on the moon. Everything you do, you're talking about trillions of dollars eventually. You're going to end up going to the moon and never get off. The Chinese and the Russians are going to be right next door. God knows where this is going to go. If you do not learn the lessons of history, you're going to repeat it. I cannot emphasize this enough. I think anybody who thinks about this seriously is going to realize we're asking for trouble. In the long run, it won't matter a hill of beans because, like I said before, we are on a technology singularity here. And eventually we'll get to the moon, we'll get to Mars, we'll do all those things. But for those of us sitting in that room, I think you're all nuts to think we should go to the moon and develop this first. It is leading to a problem that you are not going to be able to get yourself out of. And as somebody who's watched the schedule and the timeline for the space shuttle balloon way past what the original budget was, for somebody who's watched ISS and has been part of it, watch that schedule go from $8 billion to $100 billion. You're sitting there telling me you're going to get to the moon and then get to Mars by the mid-2030s. And you're seriously thinking that? How could you not look back on history and understand where the hell we've been? And I'm sorry for getting so passionate about this, but you guys who believe in the moon just don't want to face reality. God knows, I cannot imagine why you've not looked at the data. Look at the data and as one of you guys just said, get off the ground and go there already, like we did when we went to the moon during Apollo. That's all I got to say, guys. That's why I tuned into this, to let you know how I feel about it. And there's lots of stuff you can look and go out there in the literature and do your homework. That's all I got to say. Really do your homework.
All right, Larry, you know what? Everybody here respects that opinion. Everybody, by the way, has a right to their opinion. You're really lucky because everything that you've been saying has been taped. Everything that you've been saying is going to go out when the tape gets released on the National Security website. But to be absolutely fair, you have to let other people have a chance to express and even possess a different opinion. And that's, as you said at one point in time, it's all about having different opinions. Mine, I don't share completely what you have to say. You and I can have a wonderful talk about that. We're not going to do it here, and we're not going to do it now. I'm going to let it rest where it is. I think this was great having you on. I think you added some passion and some interest, and you said stuff that, frankly, I think I'm 100% behind. And I think a lot of people who have been on the call are 100% behind. The bottom line is, I think we've put a summary under this, and it's time to bring it all to a close. But I would like other people to now just, if they want to, please have something to say, just in general about this meeting today, about why we're all here, what we're celebrating, and that way we can bring this thing to a complete close. Okay? So I'm going to go down the list of everybody else. So, Michael, quick recap. You got anything you'd like to add to the meeting?
Yes, here back again. Yeah, I try to explain how I came to the time when Apollo 12 was underway. I was 9 years old. This I created here with a ship landing on the Earth. I think space travel is an allegory for the destination of our lifetime. JFK said to bring a man on the moon and safely back to Earth, where he came from. And my theory is to bring me and my family to the Earth and safely back to the destination I think we come from. It's no religious advertising platform here, no. But I see that Charlie Duke says, alone by the grace of God, we came to the moon and back. And I think now I'm 24. We must trust on God to come back and not to trust on our own capabilities. And that's the point. It's not automatic. It can end like the Tower of Babel building, that we don't understand each other anymore, and it's never happened again. Never will happen again, maybe. You can say SLS and SpaceX, and so surely 1.2 will succeed in it, but it's not sure, I think. I can share you a screen that shows me in the age of 9. Do you see it? And I was so an space enthusiast, a little bit bigger here. I don't know. Yeah, here. With 9, I continued all over the years, and now I'm the president of German Space Society, and we will see. I'm more a space historian. Of course, I'm interested in space traveling and create a spacefaring civilization. We will see. To this point, 575 people were in space. It's no spacefaring civilization, I think. And I'm watching this as space historian, how it continues. That's my statement. Thank you.
Thank you very much, Michael. And by the way, you are the only person who is interactive that is also outside the United States. That's with us.
Yeah.
And we very much appreciate that. So thank you. Now, I'm sure that there are maybe people who are non-interactive from outside the United States, but you're the only active. So we very much appreciate your presence. Thank you, Michael. Okay, Jeffrey, anything quick you want to add?
Yeah, going back to the original subject, the Apollo, two things struck me when I went to space camp in the 1980s. One, people there ranging from 19 to 70 all came with one thing in mind. They wanted to touch the future, and they came with, we can do it. We can master this. And there was one woman there, I remember, who had worked in a factory making some of the piping for the Apollo program. And to her, it was the most important, proudest thing she'd ever done in her life. And that, I think, was just one of the important after effects of the Apollo program. Comment briefly on this Moon-Mars thing. There are really two ways to go to the Moon and Mars, either way. One is governmental and two is non-governmental. Space advocates can't really do much about what the non-governmental people do, except to make the laws and the regulations easier to let them do their job. As far as the governmental projects, to repeat somebody, if you don't learn from history, you're condemned to repeat it. One of the things in public policy is it's very hard in this country to have a consistent long-term policy. If we're going to go to Mars by the government and we're launching, say, one mission every 3 years, that is really hard to sustain public and governmental interest in doing it. Whereas if the government spends its time on the governmental thing, building laboratories and outposts and testing things on the Moon, two things happen. One, it can be we can have a permanent outpost on the Moon within a decade, and it's only 2.5 days away. We can constantly be trying out new technologies. We can constantly be bringing in different kind of experts. We can be testing new things. And most of all, every night, everyone on the planet can look out at the Moon, point the finger, just like we did in the Apollo days, say, hey, part of us is up there. And that, if nothing else, would probably be the most important thing that we can do to keep the importance of going into space for people on everyone's agenda every day. My thoughts.
Thank you very much. And Chris Saram, why don't you give us your parting thoughts?
The Moon is mine. Mars is the future. And that belongs to the younger people. But I'm 72 years old. The Moon is mine. And I want to go back to the Moon. And I really enjoyed Larry, and I appreciate and I agree with so much of what he said. But still, at my age, and I'm aware of mortality, and I'm aware that whether or not anyone else likes it, that a lot of people here, the moon is ours. But Mars is for the younger people, and there are younger people here today that Mars is theirs, but the moon is mine. That's what I have to say. And this has been a absolutely wonderful breakfast on the moon. Thank you.
Thank you, Chris. Great. All right, Dennis Whipple, last thoughts.
Yes. Okay. Well, Chris mentioned she grew up in Downey, and that, of course, we're very historical with Rockwell plant there that built much of the shuttle, and I mean this Apollo, and then later the shuttle. But even Randy Gigante, when he was a member of Oasis out here in Los Angeles, him and I and Craig Ward, a few other people in Oasis, would always set up a table every month at family night at Rockwell, and we got to recruited quite a few aerospace people into the NSS, as well as touch a lot of youth. And it was mentioned by the engineer, I forgot his name earlier on this call, that you know, the engineers there were just tremendous. And he mentioned the greatest generation, those guys that had the can-do attitude, and being able to record the ISDCs. I just wanted to mention that back in St. Louis, back in 2017, there was a Space Pioneers Forum with the old Mac, they called it Mac's old team. The engineers who worked on the old Mercury and Gemini capsules that even John Kennedy came and visited in St. Louis, they did a forum at the ISDC in front of the whole audience Saturday morning, and then a second one that was a little bit different, kind of an add-on to the youth, to the young people there, to inspire them. And Lawrence talked about the can-do attitude as well. These guys really had it. And being on the archive committee, I need to make that available to people that didn't see it. I know Randy was there, but he didn't see it. But so anyway, that forum was just incredible. Amy Tittle, she's the one that works at the museum there in St. Louis, and she hosted the panel, but it was just incredible. General Tom Stafford, the Gemini and Apollo astronaut, was kind of the lead on that panel as well. But some of the members, Jerry Roberts, Norm Bechtel, Dean Purdy, Bob Shep, and Earl Robb. These guys, most of them are in their 90s, and it was just fascinating to see the attitude that they had back then that led to the Apollo technology. So, of course, all that's lost, but these guys are still alive, and it was quite a tribute to see them in person. So I'm glad to have shared that, and we'll make that available. Maybe we can put it on YouTube or something, but it just ties right into this Breakfast on the Moon tribute, you know, as well as what are we going to do for the future. And that's about it. Thank you.
Well, thank you, Dennis. And by the way, things like that, and somebody else had mentioned some kind of a file or something, we need to get this stuff out there. There is a discussions list, a National Space Society discussions list, and you people make the point on that discussions list about these files, because we need to get this to the rest of the membership, all this good stuff. Hopefully this video that we're making of this will go to a lot more people. Although we had quite a few today, this video should take in a lot more. Anyway, moving on. Jim.
Hi, I've really enjoyed the meeting this morning. I hope you appreciate my background image there. This is a work of art I completed a week ago in tribute to the Apollo 12 mission to the moon. And with respect to the question of Mars or the moon as the next destination, I know this has been a long-going debate. I think we really have to first define what we want our nearer term objectives to be in space. And I think it would be interesting to do a hard comparative analysis of, given the same set of objectives. What are the costs of achieving those objectives by going to the moon versus achieving those objectives by going to Mars, what the cost differential is. And cost has two factors here that we have to not lose sight of. One factor is the dollar cost, but the second factor is also the time cost associated with any mission. So the longer a mission takes to reach fulfillment, the less likely it will ever achieve fulfillment due to the political nature of governmental programs. So just something to bear in mind within the context of the Mars versus Moon debate. So thank you everyone for being here, and I've really enjoyed myself. Thank you.
Thank you, Jim. Okay, Gabriella, we're moving on. I want to, by the way, Gabrielle, thank you very much for bringing in not only Lawrence to speak with us, but the other two gentlemen as well. I mean, you really helped make this the success I think it's been. So just right now, I just want to tip the old hat to you, ma'am. Well done. And go ahead and give us your last thoughts.
Well, gosh, I'm young enough to just be honored to, you know, I always love hearing about people's stories of how they, you know, these sort of unimaginable, like it's hard to grasp that there were people behind those, and so that's really been one of the most exciting things of becoming involved in space more recently, is that having moved and recently going to more conferences and meeting the actual people who are doing these projects. They're human people doing, you know, these incredible technologies and standing on the shoulders of giants and et cetera. But I think just for a long time, I was on the other side of that, where I felt more, I think perhaps like the general public feels, it's really, you know, us, the general public, and, you know, the NASA engineer or the, you know, it just seems so, so amazing and unbelievable that it's hard to, it's easy to forget that this is people and teams coming together. And I think, yeah, that's maybe one of the things that can be enduring about the Apollo mission and missions. The sense of, you know, we did so much with so little compared to the technology we have today. And yeah, I think that's really, will always make the Apollo missions just really remarkable about just how much they didn't know and how much they overcame and the huge success that it was.
Thank you very much, Gabriel. And I think, by the way, Lawrence, I love the story of your spacesuit development. I think that was a piece of history that I'd never heard. And I treasured this whole recording for that alone. That was remarkable, just to let you know. Larry Ahern, Vice President of Chapters, why don't you unmute and give us your last thoughts?
Well, I all of a sudden it come running back to me, early 70s, 71, 72. I was in an airport in Baltimore or Reagan Airport, and I walked into the lounge and all of a sudden, oh, these are some NASA people. So I went over there, says hello to a couple of them. Then I started listening into these people. All of a sudden, there's a big commotion at the door, and turns out, I said, we're trying to figure out who it is, and someone said, oh, that's one of those television stars. And I said, why can't people get their priorities straight? What's really important? That's when I realized I was a geek. Anyways, but the thing is, I thought Apollo was a hell of a lot more important than some television show, but it goes to show you, it's still prevalent today. Go ahead, Joe.
Okay, thanks, Larry. Yeah, you, from one geek to another. Thank you. All right, the Redfields, Carol and Joe, last thoughts?
Thank you. I think Joe should chime in here, but he said it was a
great conversation.
Great conversation. So thanks for hosting this, and thanks everyone else for their time. That's it.
All right, Perry, you're on. Your brief comments and thoughts.
Okay. It was a wonderful discussion today. I loved just every part of it. This is probably one of our larger meetings, which is great. And the perspectives that were given by Lawrence and Michael and just everybody that presented and spoke, it's inspirational in a lot of ways, and it's grown. Joe, you have caused this to grow, and that is admirable. So that's all I have to say. Thanks for doing it. Let's do it again.
Thank you very much, Perry. And yeah, we're going to do this again. Yes, in fact, I wanted to make sure I mentioned, I should have probably mentioned at the beginning, we did a Apollo 10 celebration. That was our Sacramento Alpha 5 Society. We did, of course, the Apollo 11 celebration. Now we've done the Apollo 12. It is our intent to celebrate every Apollo mission going forward. So the 50th anniversary will keep going. And somebody else had said earlier that they wanted it to keep going. Well, the good news is we got a couple of years going yet before this is all over with. So this is going to keep happening, at least on this front. And with any luck at all, this little thing that we're doing is going to keep snowballing. And we're going to get more and more people involved. And hopefully it'll get really big by the last one. That's what I hope. Anyway, Claire and Cliff, why don't you put in your last words, and then we'll go back to Lawrence.
Okay, I will turn it over to Claire first, and then I have a concluding thought as well.
I've been fascinated by the idea of going to the moon ever since about the 1950s, and I firmly believe, thanks to some articles in science fiction magazines, that it would be possible. There's a difference, however, between my focus at that time, which was I wanted to go to the moon, and the National Space Society focus, which is space settlement, which involves both men and women being off the planet. And I think Mars would be fascinating. Yes, SpaceX and the others are doing great on the engineering of going to the moon or going to Mars, but it takes more than that. It takes the life support. And I think NASA's big contribution has been figuring out ways to handle life support. And including women, because an actual settlement would involve having children. And the difference between men and women in the case of having children is that women's eggs are with us for our entire lifetime. Whatever happens to us happens to our children in that sense. Not true for men. So it's good that we're now figuring out ways for women to live in space. And here's Cliff.
So I have two concluding thoughts. The first, when Tony Paustian mentioned Al Bean saying that he didn't mind the weather anymore, Al said that at more than one of his public appearances. I remember hearing him say the same thing, and he prefaced that by talking about when the hatch opened on Apollo 12, the first thing he saw through the open hatch was clouds moving in the sky overhead. And he realized that that was the first moving thing that he had seen in the last 8 days that was not either himself or a fellow crew member or something that they had set in motion themselves. This was the first thing outside of himself that he had seen move. And so that stayed with him. And I think it's important to realize that, as he did, that there are things outside of ourselves that move too. And that's our connection to the rest of the universe. So my other thought is back in the early 1990s, the National Space Society did a tour of Russian space facilities, which I was privileged to be a part of. And one of the moments that will stay with me forever is standing in Yuri Gagarin's office. And I remember at the time thinking back and as a preteen or early teenager, I had been reading about Yuri Gagarin's office and thinking that I would never be able to stand in that place and see those things because it was on the other side of the Iron Curtain, and of course that was impossible. So that trip in the early 90s to Russia opened my eyes to the infinite possibility of life. You should never say that anything is impossible for yourself or anyone else. And I no longer think that it's impossible for me, even at my age, to someday walk on the moon. I think it's somewhat even probable that I will at least make it to Earth orbit, but it's not impossible that any of us will find ourselves walking on the moon someday. And that's it for me.
Thanks, guys. Thank you, both of you. And before we end with, I want to actually just do a real quick round the table here of the people at the SACL 5. Really quick, just brief comments.
Yeah, I think we ought to move toward our private sector.
And speak out really loud.
The private sector is the way to go. I think we've determined that today.
Okay.
I enjoyed this very much. I particularly like Randy Johnson's presentation and insights that he gave, and I look forward to the next one.
Thank you guys for joining in and giving us as much understanding as we can possibly get. I did want to say that Jeff seems to think that what I understood his comments are that the moon is for government and Mars is for private, just because of the distances involved and the time periods involved. There's something to be said about that. And honestly, I don't like the idea of having all our political crap going to Mars. So let the governments have the moon. Okay.
Okay. Thanks, guys. So, Larry, you're going to get the last word, except for me. Actually, yeah. So as soon as you're done, I'll have just a couple of things to say. And then we'll be ending this I believe, very successful breakfast on the moon, part 2. Okay, Larry, you're on.
Okay, first of all, Joseph, thank you very much for organizing this, because it's great to have a round robin. I always wanted to be on a panel that got some of these thoughts out. And from my own perspective, I tend to get passionate and emotional about stuff, and I realize I probably get more passionate and emotional than I should when it comes to this, because I've lived through so much of it, and I think I can look at it through both eyes and both sides of the story. And I view myself as the underdog when it comes to Mars right now, because basically I'm not trying to convince you about my opinion, because your opinion, the Moonies I call them, is already cast in concrete. This is the way we are now scheduled to happen. Monies, budgets, everything else is targeted to the moon and a 2024 landing of a man and a woman. So I'm sitting here shouting and yelling, not because I'm suppressing your opinion. I'm trying to give my opinion, which is definitely an underdog opinion right now. And I just want you to know that. I tend to get much more passionate than I should, because I feel like I'm up against it. And it astonishes me, that famous phrase, those who ignore history are doomed to repeat it. So having gotten that out of the way and having broached that line, those of us who failed to take into history doomed to repeat it, I implore you all to watch C-SPAN in the coming months, because C-SPAN is doing the coverage of the House Space Subcommittee, defense of the NASA budget, for 2020. They've just finished doing it for 2019, and they're about to start doing it for the out years for 2020 to 2024. The new NASA administrator, Jim Brunstein, is on the hot seat, and he has been quizzed back and forth by there's about 10 members of the House Space Subcommittee that are going at him, and his deputy, guy's name I forgot. He's an astronaut, but I think. But anyway, so I ask you to watch these hearings, because in watching the hearings, you're going to hear all the members of the House Space Subcommittee. Oh yeah, this is a great thing, and we should do this. But the kinds of questions they ask are not disappointingly, they're not from the knowledge base that everybody in this room, everybody who's watching this has. There's a lot of naive questions that they ask. But when it comes to the money, they are drilling the same kind of questions that always come up. Okay, it sounds great. We've got the 2019 budget underway, but now NASA's asking for another $2 billion in 2020 for the 2024 landing. And it's going to be more than that. And once you hear these questions start targeting it on the money, the defense, compared to other programs, why should we do this as opposed to education or as opposed to medical, or those are the kinds of questions that are being asked? Well, then the answers that are coming from the administrator get pretty on thin ice. And that's when you start to realize very clearly that we're ignoring history again. This has happened before. It didn't happen in Apollo because JFK gave us a blank check, but it certainly happened on shuttle. And for God's sakes, it's happening to, multiples of 50, well, let's see, maybe it's 30 on ISS. So it's very reasonable to assume that this is the kind of thing that's going to happen in a gateway in a lunar program. No matter what anybody says, this is going to happen because it's history. And once it happens, it's gonna push everything to the right. And so I agree. It's almost, I've come to the same perspective that has been repeated now in the last couple of minutes. If you want to go to the moon, let the government do it. My perspective is, if you want to go to the moon, let the Space Force do it, because this is beginning to become military. There's no question this is going to become a military base. You're down there and you can look on there. I've said all the reasons before. So if that's the case, like Trump has got his budget and the Republicans want to do this, they've got a Space Force. They can do it. But to shoehorn NASA to do it, to me, I just think it's the wrong way to go. And so therefore, you're boxed into a corner. The way to go to Mars is with the private sector. And lastly, let me just read to you from something that I just gave to Gabriella. She can circulate it. She's got it on her email address, but let me just circulate it to you. One brief paragraph, and I'll stop talking. There's something about species preservation that we should all be thinking about, which is this: Mars, not the moon, is the only backup to an existential threat to humanity. Now, if you think about what an existential threat to humanity is, it's not only an asteroid, it could be a plague. It could be something that bubbles out of nowhere. It could be some immune system defect. It could be stuff that we're conducting experiments on our precious biosphere. Uncontrolled experiments that we're conducting that are obviously causing the climate change disasters that some of our leaders refuse to acknowledge even exists. We are doing stuff to planet Earth that is unspeakable. By the way, I've written a novel about this. It's called Cassie's Guess, and it's on Amazon. And those of you who wish to read it, it talks all about this and how the only way we can deal with this, that Mars, actually, it all happened on Mars first. And we need to look at why it happened on Mars before it's happening here. Aside from that, if you acknowledge the fact that there's an existential threat to humanity, then you realize also that Mars is the only place that has all the resources needed for long-term human settlement. And then you have to ask yourself, do you want to delay that at the expense of going to the moon? Because if you do that, and everything that's involved with it, you are gambling with humanity's survival. I want you to remember that phrase. You are gambling with humanity's survival. You could pick up the newspaper tomorrow, and any one of a number of ways, you could suddenly realize that our very existence is threatened, and not in the long term. It could be tomorrow. Just keep that in mind. Do you want to spend another 20 or 30 years going to the moon and developing the moon before you go on to Mars? That's the thought I want to leave you with. And again, Joseph, that's a fabulous a group of people that you've organized. A lot of different ways of communicating, a lot of different opinions and stuff. And Apollo 12 and 11 was fantastic. All those missions, sitting at mission control, highlight of my life, no question about it. But thanks for doing this, and hopefully you can do it again and do it bigger and greater.
Thank you very much. Now, I'd like to I'd like to thank everybody, but it turns out we have 3 more Q&As. I don't want to ignore those who have, the only voice they have is the Q&A system here. And so one, Matthew Polnick says, and by the way, I'm not going to ask for an answer to these questions. This is kind of just their opportunity to get their voices heard. I'm just going to read them. So everybody should just not speak, please, because we're about to end this. Robert Zubrans, The Case for Mars, outlines the chemical processing required to process fuel and oxidizer for a round-trip mission. Does anyone disagree with this method? It is well understood and a relatively simple technology. Thank you, Matthew. Michelle Foreau says, of course, I'm not a scientist, but a guy named Gerard O'Neill, not sure of the spelling, he's now deceased and taught at Princeton. His theory was that it is less expensive to shoot the resources of the moon to build, say, the ISS, and all the resources are on the moon, according to him. This is less expensive than shooting a rocket from Earth. And Deborah Pollack says, did everyone forget about Gerard O'Neill and the High Frontier and L5? Shouldn't building at LaGrange still be a part of the discussion at some point? I would like to add as a punctuation mark, this is the Sacramento L5 Society. We were one of the first chapters of the original L5 Society, and obviously we bought into the dream that Gerard K. O'Neill wrote large for us so many years back, and that helped really to move so many people in the direction that inevitably led us to the Apollo program, and even now to today. So that's all we're going to say, and I'm going to just withhold my own thinking. I obviously have my own thoughts, but as moderator, I think it's only fair that I kind of hold that back and allow this meeting to essentially stand on its own as is. So thank you, folks. And I'm now calling this meeting to a close. Bye, everybody. You can all leave and have a great night, everybody. All right. All I'm doing now, I'm turning off the record, and then I will be ending the meeting. So bye-bye.